button. So today's class is a little bit more a conversation about go to the right slide. It's going to be the first kickoff meeting of our second half plan review series. So we did plan review in the first quarter, the first 6 months of the year. We're going to do plan review again. Again, breaking it down the first Thursday of every month, breaking down a different section of the energy code to see how it relates to plan review. Today is more of an overview of the whole plan review process when it comes to energy code compliance, to kind of tease out some questions and conversation points that we might want to be thinking about before those weeks come up, or just to handle it separately. But it's really a conversation, again, just to kind of get us started and get that ball rolling. One of the things that I think is fundamental that when we do any type of work is that when we understand the why behind something, we can figure out the how. Now, we will be, just as a reminder, because I know that it looks like we got mostly just Amarillo staff on today right now. Just a quick reminder before anybody else jumps on, we are going to have a little bit of a test prep class on Friday the 18th as well, if that works out still. In the afternoon, where we'll actually be going through the ICC certification process. So it'll be, we'll talk about what test preparation, run a couple questions, show how to do it. Maybe do a couple timed questions in that. So if you're not already signed up or you have questions, feel free to reach out to me so we can clarify that. But I figure I'll say that early before anybody else jumps on, and then it becomes a little bit. It's gonna be an internal training. And I didn't want to make it too many people aware of it before we get, inundated with questions. But again, that'll be the plan for that day. Little quick note there. I'll delete this from the recording. Anyhow, back to what we're talking about. So again, understanding that why is fundamental to figuring out how we're going to accomplish it. So when we think about the code, whether we're talking when we think about the 21 residential construction code, one of the things we're talking about is, or recognizes that the code is designed to provide us some minimum expectations, some minimum guidance on how we build buildings. And when we think about what's going on in the Panhandle region and the various communities that are there with building departments, we're looking for some consistency from the code's perspective on one of those minimum expectations. And we know that there are people coming in and people coming out. And part of the problem is contractors move in, contractors move out, and they come with questions of, this is how we do it here, this is how we do it there. Well, the reality is by creating or adopting model codes, hopefully we're eliminating some of those negative construction methods, right? And this becomes more of a standard uniform way of constructing buildings. Now that's how we take the residential code, right? Chapter 11 gets into the energy code to the extent that we adopt it, or if we choose to go with our own specific energy sections or adopt the IECC, we understand the IECC's intent was to provide a method of flexible compliance that would provide for the effective use and conservation of energy over the useful life of a building, right? It's all about flexibility. It's giving people options that we traditionally may not always think are there, but are really there, and to be innovative and to look at how technology is changing. When we think about one of the things we're going to talk about during Coffee and Codes is we're actually going to look at some of the differences between the major difference between the 15, the 18, the 21, and maybe even the 24, to kind of get how things have changed over time and how they're really, in a lot of ways, they may have changed, but that they changed enough to where you notice, right? And so I think that's part of that understanding is the code is designed to be flexible, whether that's the 15, the 18, or the 21. And I know we have all three codes within the Panhandle region. And so understanding that means we also have to back up a step and look at the scope of the code. Now, I have jurisdictions that I work with that have chosen to maintain just the Chapter 11 and not adopt the IECC to make sure they keep separation between, residential code, residential energy, versus what we see here, which is the scope of the residential provisions of the IECC extends beyond single and two-family dwellings and townhouses into group R2s, R3s, and R4s that are 3 stories and less above grade. So again, some jurisdictions have started to kind of whittle that down and say, hey, if you're a hotel, you're building it by the building code, so follow commercial provisions as well. And I think when you look at that, you'll see that there's not that much significant difference between the two. But again, it's an option. And it's why I think it's important to bring it up in the scope conversation. We start talking about wholesale, the overview of how we review plans for energy compliance. Because when you think about it in the context of the commercial side of this book, of the energy code book, you see that code applies to commercial buildings, and commercial buildings are designed as anything that's not already defined as residential. And so again, you get that kind of which section do I use, right? And so a lot of times, again, I see jurisdictions doing that to kind of individualize their own approach. But one of the things we saw in the 21 code, 21 residential code, was again the starting to separate these concepts of the townhouse and the townhouse unit. Townhouse is still there as a building that contains 3 or more dwelling units, but the townhouse unit is more that singular dwelling unit itself, right? That extends from roof to foundation. Because what we're trying to do is make sure that we don't have common spaces amongst some of those areas that really become areas, or more importantly, in some of those condo associations or townhouses, where we start to have uncontrolled air movement, heat loss, heat gain, whatever we're thinking about in the context of the environment, but that those don't affect the individual dwelling unit. Too many times what we'll see, especially in some of those townhouse units, is maybe a unit that becomes vacant, or more importantly, more than one unit that becomes temporarily vacant, at which point then that remaining unit is now paying to heat or cool potentially leaky building neighboring units. So again, understand that I think it's important that we understand when we think about the context of general plan review, we're looking at not just one singular concept, but we're kind of expansive in what we think when we think energy code. Not just in the components of the building, but also the types of buildings. Remember, because again, the energy code is saying we can expand the residential provisions into what would traditionally be considered R2s, R3s, R4s, right? And so when we start talking about those assisted living facilities, those congregate living facilities, we start talking about some of those things that maybe we weren't always thinking of in the context of the IRC. They may come into the IECC, right? So when we think about plan review, and I think this is, again, help us to guide ourselves when it comes to how we think about the plan review process, I tend to think about, and I usually focus my energy code compliance into the 4 pillars. Now, we had worked on, if I could reach it, if you remember, the last time I was out in April, we had worked on this little inspection guide to help address some of the concept of field inspections. I'm in the process, and maybe I'll have a draft by the time I get there in 2 weeks for a plan review guide as well for energy code compliance. Again, not necessarily a step-by-step, but in more of an overview and some of the higher level concepts that we're trying to apply, so that when we hand that, so maybe we can educate and inform our designers and our architects and some of our smaller builders who are thinking, what am I looking for, right? So again, that's part of what we're trying to do here, is come with what are those main talking points, and how do we really get them get compliance. So in that context, the 4 pillars that I see: building thermal envelope, mechanical systems, surface water heating systems, power and lighting, right? Those are the 4 components. And within that building thermal envelope, we talk about both the insulation, the fenestration, and the air barriers. But all of that is based on this expectation that we need construction documents, right? That there is certain information that's going to help guide construction, and that's going to be provided in the docs as part of our plan review process. Section R105 gives us a list of information that's supposed to be on those documents, right? To help facilitate code compliant, right, designs. So when we're doing that traditional plan review process, we can throw in these expectations. Now, there are different ways, and we talked about this a little bit when we were there for the in-person training a couple weeks ago. There are different ways to do this. There's the holistic approach to plan review where you do everything. You get one project, you do it all, right? At which point do you take it page by page? You take it book by book, section by section. There's also the opportunity to have what we call segmented or specialized plan review, where you may have, a set of plans examiners who do the structural components and some of those, and then you have a different set of people that do the mechanical review. Someone else does the electrical view. A person does the energy review. So there's different ways to approach energy code compliance, and each jurisdiction is different in how we do that. But if we follow what the code tells us, really the only difference between the 15, the 18, and 21 is that in 21, we specifically call out energy compliance path as one of those things we need to know and what identified written on those construction documents. And I think whenever I do plan review, energy compliance path and code addition are the first things I look for. Normally, and I'm old school, I still use pen and paper and then type it up into a comment sheet. This was for yesterday. And what I tend to do is at the top of that list, I'll put down my climate zone. Obviously, we know where we're in climate zone 4. I'll put down that compliance path because I need to know every time I think back to a comment or to a page, okay, am I looking prescriptively or am I looking at a report? Most projects, let's be honest, come in as, especially residential, come in as prescriptive. Now, in the 21, you get a little bit more expanded idea of what of some of those options, right? In the 15 and the 18, we have prescriptive compliance and we have total building performance, right? Where we're calculating dollar values. In the 21, we start to take performance and say, well, performance can be rated, can be identified 2 ways. You can either do the mathematics and figure out how much it costs to run this building based on a 365-day calendar year, or you can calculate the performance based on a grade scale or an index, right? We typically give that index a number, with 1 being amazing and 100 being, you probably need to do some more work. But ultimately, I tend in my brain to turn around to grades, right? Did you get a B or did you get a C, right? We're looking for a C, minimum construction building. That's all I need. If you want to go for a B, go for an A, go for it. You've at least passed what I need. ERIs are generally put down as a numeric value. So let's say I'm looking for a 52. I need a 52. If I get a 51, I'm doing better. I'm getting closer to 1, which is perfect, right? And so again, that's I think important to understand when we think about what it is we're reviewing. If I'm looking at projects following prescriptive compliance, then I'm looking at the book as the mechanism to compare it to. If I'm looking at one of these 2 compliance alternatives, then I'm looking at a report as what I'm comparing it to. So it really does become a question of what's the document I'm using. Now, one of the things I really push, especially in large scale, larger homes, multifamilies or commercial, I like to see that ComCheck, that performance report, that ERI report actually put into the detail pages, right? As its own set of pages. I hate having it as a separate report because I know what happens to separate reports when you get onto the field. They disappear. No one ever sees it. No one has any clue. But if it's like page 3, then, and all the pages are on there, then we can better find, okay, if I'm changing this, how's it going to affect that? So again, those are considerations to think about, conversations to have, and suggestions that we make a lot to teams when they build projects. Like I said, understanding that compliance path allows us to better identify what we're looking for, right? Are we listing it in this chapter 11? Or are we listing it as chapter 401, right? Section 401 in the IECC. Do we give it a number, right? This one here is saying number 4. What does number 4 mean? Well, number 4 means this. So it's an energy cost calculation or a compliance path where they've listed a number. Well, that's not, unless I know what that number is, it's not very helpful. So we try to make sure that we identify prescriptive names. Use names like prescriptive, total building performance, right? Energy rating, That way we know what we're talking about, or we can reference those specific sections of the code. The only problem with listing some of that prescriptive is, again, prescriptive is there's more than one way to show prescriptive compliance, right? We can show prescriptive compliance by the use of either a res check, looking at the total assembly, the total U averaged U factors. We could look at it as an R value, right? So there's different ways we can look at prescriptive. If we're looking at a building that's following a IECC compliance path number 2, well, what does that mean? Well, we assume based on the report that they're talking about it in total building performance, right? But it's nice to have that extra performance in that list, just to confirm. Then we've got the ERI, the Energy Rating Index, right? So again, we're going to get different documentation based on those compliance paths. Now, with those 2 performance compliance paths, I think it's, again, I just reinforce, you're going to get a report at the beginning prior to plan approval, and then you're going to get a report at the end prior to final inspection. That you do inspections, don't get me wrong, we do inspections throughout the process, but with those compliance paths, there's a third party coming out there and doing that, verifying that those systems are installed properly as well, right? So they're going to say, we're expecting an R21 in this wall. We came out, we verified the R21, and now we can run this report. And it does perform at the end the way we thought it would from the beginning. Depending on your compliance path, that can have some impacts, but we'll talk about compliance paths in a much deeper conversation later. Today, we're just thinking high level. Beyond that compliance path, we get into the concept of the insulation, the envelope, right? That thermal envelope that separates our environment from the interior occupied spaces, that allows us to control conditioned space from non-conditioned space. And so what are we talking about? What are we looking for in that? Well, in that, I say we tend to look for these 4 concepts. They're identified throughout the code in different subsections. We're looking for that envelope location, right? Because if we have that envelope location and we know where we're looking, right? Because that's part of what, if I walk into a building, and I had this conversation with a designer the other day, where they said, well, I said, well, where's your where's the depiction of the thermal envelope that's required by section 105.21? And their response was, anywhere there's insulation is part of the thermal envelope. Are you sure? Right? Because if that's true, then I'll use my pen here. Then when you installed insulation in this wall, and in this wall, and in this wall, and in this wall, here, 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 and here, are those all separate conditioned spaces? Well, no, that's a sound attenuation. Well, then let's be clear what we're saying. I tend to you guys have seen me, known me, heard me long enough. I can get kind of grumpy. And so, a flippant response from a project designer usually gets a flippant response from me. And I'm glad I don't work for any jurisdictions anymore, right? Because again, saying something as simple as all insulation is going to be part of the thermal envelope. You put insulation between those up in that ceiling area, and then but is this ceiling going to be vented or unvented, right? It's not a simple conversation of all insulation. It's too easy of an answer. We need to know where these are, because if I know where there are, then I can better perform my inspections as a building inspector. Once I know where they're at, then that can affect what they are, right? It gets more into that concept of what is the insulation being provided. Because if I'm looking to control, we see here some batt insulation versus some different types of maybe spray foams or different materials being applied. So again, we can have each material. We know that insulating materials do different things. Not all of them just simply resist heat transfer. Some can also resist airflow, right? So if I'm installing a rigid insulation or a set or a type of or certain thickness of spray foam insulation, like we like to do, that's going to have a different impact on my building assembly than if I just install mineral wool, or if I just install some type of bat insulation, fiberglass bat. So beyond the material differences, I also know there's insulating differences. And so I can't just say one is just like the other and call it a day, right? We're going to have some deeper conversations about what it means to review for insulation. But again, we're looking at two different types of values. We have an R value, which represents the laser out. R value, which represents the thermal resistance rating of that singular material, versus a U factor, which is looking at how much heat transfers through that entire assembly, right? So we know that most walls aren't just single component. They're part of drywall. There's going to be cladding. There's going to be sheathing. There's going to be barriers and all of these different components in that assembly. And so we're going to want to make sure that we can take advantage of all of those different thicknesses of material and the different thermal resistance ratings of them. Now, one thing I point out is in my particular home, which is a little bit different than maybe the one across the street where the lady Annie lives, my house is closer to the state route. And so they installed a thicker drywall intentionally on my walls. They insulated my exterior sheathing, or insulated my exterior cladding, right? The vinyl siding got sheathing, got foam installation behind it. That's different from my neighbor. And so again, we both have the same R13 in the wall, but we don't have the same U factor because of the differences that maybe existed. Again, mine was for sound attenuation. I guarantee that when Bill was building this house, he was not thinking, oh, I bet I could insulate a little better with an extra 1/4 inch of drywall. But in essence, he did, right? Because again, we understand that those are different systems. If we have designers that have questions along the way, we've got a variety of different trainings we've done over the past 2 years that can help in assisting and understanding those processes. And so we can always send that information out to those that might need it. But again, we understand that there are a variety of different materials that provide that thermal resistance, and that those different materials come in can provide additional qualities to them. Right? If I'm using a mineral wool, I might have more water resistance than if I use a cellulose. If I do a blow versus might be easier to install post construction versus a spray foam, right? Or a bat. And again, I might get some thermal or water resistant nature through different types of rigids and sprays that I don't get through bats and blows. So again, there's different types of things. And one thing I think is important to understand, again, reinforce. And we'll talk more about this when we get into the insulation specific plan review concepts. But we understand that if we start modifying, changing these systems, we can impact more than just the thermal value, right? It's not just making sure we have an R10 and R13 in the wall or an R19 in the wall. It's also thinking about how does that affect water resistant barriers, right? We want to make sure that we don't create a situation where we originally spec'd out spray foam and decided, hey, I don't want to wait for the guy to get here. We're just going to go ahead and bat it up. Well, did you think about the location of your water resistant barriers, your air barriers? Because that spray foam was going to do 2 jobs, and now you have to find a replacement to make sure we don't have water accumulation, moisture and humidity getting into, or like we know that happens once in a while, that dust that blows up from the east coming in and then filling up some of those spaces. Again, spray foam will not be affected by the dust as much as maybe some of those types of bat insulation. And again, we know that there's methods of calculating, and we've talked about that. The tables exist for us to compare that prescriptive compliance option to. And again, we see there different values provided. I don't think I have one in here that shows the multiple years at once. I don't think I put that in there. I should have. But again, we can see how we can start to move, modify, change some things and really affect how that building's total U factor is impacted, the assembly, just by moving one piece of material. One thing we're going to be talking about in one of our future sessions is the role of maybe the ASHRAE Appendix A. In the 2024, there's an appendix that might be useful just to print off as an example. Appendix A is a good one to print off as an example. What Appendix A, and I think it's 24 IECC Appendix RA, do is it's either RA or RJ. I know it's one of those sounds. They provide a series of just alternative designs, right? They take things like the roofs, the walls, the floors, and just start giving them, what's a U factor based on this R value and this thickness of wall or this type of insulation, this type of concrete versus block, wall design. So again, it gives us some options there to help make life a little easier on calculating those values. But after we got those values designed, right? Well, here's one I had. I've got the different designs. We once in a while we want to make sure that we think about the type of information we're getting. We don't want something that says, "Hey, I'm doing I'm doing a 2x4 or a 2x6 stud. They're going to be at 8/16 on center, so just insulate and put a vapor barrier per the code, whatever that means." Well, that's not helpful because depending on our climate, depending on our code, we might have completely different values we're looking for, right? And so again, what we're trying to do is make sure that, yes, I know what the thickness of or where you're providing or requiring this insulation, but I need you to tell me what that R value is as a designer so that I'm not making code decisions. You're making decisions for the design. And so once in a while, that means providing a comment that says, "Hey, we need you to specify those R values or assembly or U factors to demonstrate compliance, because we're not going to make up optional things throughout that process." And like I said, I need to go a little faster. We're going to run out of time. So some of the things that we think about in this overview of plan is, again, what types of windows are we installing? Again, what are the U factors or solar heat gains? How's that information provided on our details? Because if it's not there, then we have to make up things, make up decisions or wait for responses. One thing that I like to point out, I know all jurisdictions are different. We talked about this a little bit last time I was in town. Where some jurisdictions charge for that plan review time, right? And so if I have to come in and spend an hour looking for window details because you gave me a spec book, and especially when we talk about large scale commercial projects or larger residential multifamily projects, if I've got all of these windows and I don't see any thermal values and I don't have a simple minimum maximum value there, then I'm going to be reading things, and that's going to cost time. Either that's going to cost time that the city's not going to recuperate, or it's going to increase the cost of a permit because I'm spending that much more time looking. Again, I've had contractors, especially on large projects, look to who will say it's in the specs. Okay, well, you understand you gave me 3 volumes of specs worth about 3,000 pages. So if I'm supposed to read 3,000 pages to figure out what the U factor is on your window, you're getting a bill for that, right? At least we're in my jurisdiction, you're getting a bill for that. And so again, that, and part it's not just a question of billing, it's also a question of time and efficiency, right? As an employee or as a supervisor, I don't want my staff looking for 3 hours reading reading spec books when we've got 15 different projects that need to get done. Right. So again, that becomes one of those things where we start to work with our plans, our designers to say, "Hey, put this somewhere on the detail. Give me a spec book reference," right? So at least I could go to page 357 of 3,000, or put again some basic values in the construction details, right? Either back in the upfront details at the very first beginning of it, or somewhere. A lot of times you don't get a lot of those details in residential, maybe on page 1 or 2, but again, that's where it's important to have it. Again, once in a while we may get a com check as part of our design, or res check as part of our design. And so we're going to be verifying that what we've proposed in those windows is actually what we get, right? And so we see here a proposal that says we're going to have a, where do we go? A solid door, 0.32, but we have a solid door over here at 0.37. So which one is it, right? We have fixed windows and operable windows at 0.37. Well, this says 0.32. So are we going 0.37 or 0.32? I need to know. And so again, and then I get back to the table and it says it's 0.30. So we can get variation. And again, this is one of those things that I tend to really get into commenting on, is the inconsistency that exists. Because what's going to happen is my inspector is going to show up on the site and say, "Hey, you need to have this window because you got a res check that says you're supposed to have that window." And they say, "Well, no, our approved plans show this." Well, right, that conflict will then naturally exist in the field that shouldn't have to exist if we take time and verify that all the numbers are the same. And then when we get into mechanical load calculations, which we'll talk a little bit about in a couple weeks, that can impact mechanical load calculations. So if I've got a contractor or inspector or plans examiner looking at mechanical loads for residential structures, and we've got windows that don't work the way they're supposed to, that can affect how that equipment is going to work in the long run. So again, provide those details. If I have to keep looking for them, it's going to be a problem. And my inspector needs to know what he's looking for when he goes out in the field to be both compliant with, and where we get those values are going to come from the manufacturers, and they're going to have, again, if we don't have that manufacturer's information, then we have to apply some the code's default values, which are not going to be helpful. And we've talked about that before. We'll talk about that again in a couple weeks, a couple months. Also, we look for those air leakage concepts, those air leakage controls. How are we testing? Are we visually inspecting? Tell me up front what we're doing. There's nothing worse than going out or not having that information and then trying to find it out later. If you're not going to do testing, just say up front that we're going to provide visual inspection of the air barrier, right? That we're going to have some evaluation that says we're going to you're going to use a thermal camera to perform, give me something. I understand, and we talk about this a lot, there's not a lot of raters or people with that kind of capacity in the Panhandle region, but we can give some detail on what we're looking for, right? If it's not going to, what do we approve as an alternative? Is it going to be a visual inspection, or is it going to be that we've sealed all openings or in penetrations? Give me some descriptive method to verify that we've considered air leakage as a whole. What we're hoping to do, and again, this will be a fun conversation, we're going to try to get with the Builders Association and a local builder, and maybe sometime sometime soon, I'll just give you that much, we're going to try and do a smoke testing of an actual building during one of the Panhandle happy hour with a builder concepts. So again, we can invite building inspectors, contractors, and we're going to have a barbecue. We're going to smoke barbecue and smoke a house at the same time to see how much air leakage we're getting out of just standard construction, right? Again, and how can we easily identify it, right? Is it just smoke it up with a smoke machine and then just start putting tape on the wall so we know, hey, we're losing air over here. Let's seal it, right? So let's get some caulk and seal it so that, again, we can control how much of that conditioned space is leaving our buildings. So again, that's something we're thinking about to facilitate this concept out in the field, because we know that, again, that's a big issue that a lot of people have questions about. How do we do it, especially when we don't have somebody who's always there available to us as one of those raters or a blower door operator. So again, the code gives us a variety of different expectations associated with that, and the types of systems that should be looked at. So we'll get more into that as we get into some of those air barrier conversations and testing requirements. The code also obviously expects us to not just look at the insulation. Energy code is way more than just insulation. And the thing that I think, once we've got past the concept of proper insulation and air barrier installation, then we get into the thing that really, really affects how a building performs. And that's the mechanical systems. Because that's what actually uses energy, right? We don't wire the drywall. We don't wire the windows. We don't wire the air barrier. We wire and spend energy, whether that's electric or gas, on mechanical systems and lighting systems. Now, we'll see here in a second, lighting is a little bit, is still a simple concept in the 15, 18, and 21 codes. But what we really get into is, again, what is the mechanical design? Those expectations are supposed to be provided as part of this compliance. So a lot of times, again, I get projects. I just turned one in yesterday. It was a brand new residential home. Thanks for sending me the information. I did a review of the structure, but what you did not send me is a mechanical sheet. I don't know how you're getting mechanical ventilation to any of the rooms, right? Ventilation, space conditioning, what's the equipment? I see you have a mechanical room, but how do I get, where's the duct work going? Are we using ducts? Are we using ductless? What are we doing? Right? And then I got Plumbing. I see where you have a fixture identified, a toilet or a water closet, a sink, but you didn't give me any information about where you're locating, what's the size of your water heating system, what's the, how we're piping it, how long those pipes are going to be. None of that information is provided. Same thing when it came to lighting. Oh, I appreciate you putting a page E in there to tell me how the panel was going to be organized, but that's the end of it. There are certain things that I'm going to need. And so again, that's where this is, again, is why it's important. And we'll have deeper dives into mechanical systems and power and lighting systems, again, as the months go on throughout this series, this plan review series. But but again, understanding why we're looking at information, why we're looking for that information is really important to figuring out how we're going to get it in, how we're going to provide that space conditioning, right? We understand that that's what's using the energy. That's why we need to know how it's being designed. And then with knowing what it is or how it's going to be done, then we can evaluate what they're utilizing in that process. And so again, to me, mechanical, simple thing. The simplification of it is there a proper design? Is there proper, is that, and again, that's a conversation that really does create some conflict, right? What is the manual J supposed to have in it? Did you do one? Did you do this right? How do I evaluate it? And I've had conversations with contractors and plans examiners alike across several jurisdictions and across the country, is this my job? Is this not my job? Where's the line on what the expectation is? And so I think that's part of what we need to understand. That's why we're going to take some time to kind of get into that manual J, into that mechanical design. But again, proper design is important because we can't just take the word of a installer. We need some kind of analysis that says, based on the elevation, the heating, cooling, the amount of glazing, the level of insulation, all these different factors, how much heating and cooling is going to be needed for this building. Now, remember, the code says we have to provide heating to a 68-degree temperature, but both the mechanical provisions, the mechanical code, and the energy code say all three say, if you're going to provide cooling, that system has to be designed to a standard, right? We can't just say, here's the air conditioner. It'll get you close, but it will never provide what you want, right? Because what would be the point of having a system that's never going to get me where I need be? And so I'm always going to have open windows anyhow and have uncontrolled ventilation, right? If I'm providing mechanical ventilation, mechanical air heating and cooling, then I need to make sure that I'm applying some type of design. And that's where the manual J, manual S, manual Ds come in, to make sure that we're providing not only the appropriate calculation for heating and cooling loads, but then how are we sizing that equipment to meet that need? And then how are we distributing it so that, again, we get the right amount of air in the right spots to perform the way we want it to. We've all seen designs and installations that are ineffective at best. We've had oversized fans that shoot out so much air it blows the papers off desk every time it activates. And we've had systems that provide so little amount of air that they're useless, right? We're not getting any temperature change in that impact in that area. So again, we want to make sure that we're thinking about those systems, whether that's something that's done in the field or done as part of a upfront plan review. Again, I get they're sometimes submitted as part of a phase submittal process, but again, we want to make sure we're evaluating them, and we'll talk more in detail about that later in a different webinar. Again, what we're looking for is those. Not only do we look at the proper design, but we also look at the proper equipment efficiency. Now, for the most part, this is going to be something that's handled mostly through federal law regarding the manufacturer impacts the manufacturers. One of the things that I'm starting to see more and more, especially with the change in the A2L refrigerant requirements, and again, this is one that I personally know of just because of I went to go buy a new air conditioning system. I have a two-stage system, and so when I went to go buy the components or talk to them about buying the components, I got we've got an outside unit that works with 410A. We don't have any But we're going to run out of 410A real quick, so we don't know if we can actually charge the system once we get it to you unless we do it right now. What? And then if it once we run out of 410A, or we know 410A is getting more expensive, so if you do have to recharge it, it's going to cost you an arm and a leg to do it. Okay, so let's go with a 454 A2L refrigerant in this system. Okay, well, yeah, we can do that for you, Mr. Harmon, but we can get you the outside unit, but the inside unit is going to be about 9 months. It's not, they're behind in manufacturing. So I'm going to wait 9 more months to get my air conditioner fixed. That's really helpful, right? And so what we see a lot more, and again, I not only personally, but again, I see that in plants. I see plants all the time where it comes in and you see that item identified as a 410A, and it's like, are you sure you're going to get that? And then what impact is that going to have, right? You want the right efficiency, you want the right BTU, but now how's that going to affect me? You know, is this something that we're going to have to think about its location within or the location of piping systems, right? And what the code currently and in the future says about those piping locations for A2L refrigerants. We could talk about A2Ls all day long. I've done a series of different trainings on them. But again, it's one of those conversations that I'm seeing more and more, both in the residential and mechanical side, where we're coming back and saying, hey, we need to change out the system. What do we need to do? Here's the requirements for an A2L that are different from an A1, right? And so you're gonna have to add this, do this, change this, and you know, how does this affect the efficiency or the size of equipment that you're going to get? Because these are not just simple coil changes. Some of these, you know, you can't just change out a coil and add a different refrigerant. Those refrigerants go to different pressures, which can affect the coil and what it will and will not allow. Different oils, all that stuff. So anyhow, so again, we start to evaluate how those mechanical systems work. And when we start talking about swapping out systems, don't even get me started, right? We'll talk about that a little bit more as we get into it, but we talked about this in the plumbing class last week. If we start taking out certain things and swapping equipment, it really becomes a question of what are you doing? Are we replacing a existing 40-gallon storage water heating, 40-gallon storage tank that uses gas with a that maybe has a BTU rating of 40,000 BTUs, 45,000 BTUs, and we're replacing it with a 200,000 BTU, 199,000 BTU tankless system? Well, we're impacting how much gas goes into that. So it's more than just changing out the equipment. It's also about looking at the full impacts that it might have. Is everyone's going to say this is a more efficient design, unless it costs me a lot of money to replumb my entire gas system, right? So again, there's going to be some considerations and regulators come into it, and there's a lot that we could talk about when it comes to mechanical designs. Again, we'll talk about applying mechanical requirements in greater specificity in about, I think, in August. Again, distribution ducts. The code gets into whether, again, we're in 15, 18, or 21, into when we can have different types of, what are the expectations for those distribution systems? When are we looking for, when are we required to provide insulation? When are we not? What's those expectations? And so again, we'll get more into duct systems as we get along, but having that duct detail is really going to be important, because that's going to drive our idea of where we need those controls. The code currently says you have to have one control per zone. There has been conversation, although none has taken hold yet, so I'm keeping an eye on it. But one of the things that has come up several times is, how do we calculate and where do we control? Do we control at a central location? Do we control anywhere in the building? Or do we control at the longest, furthest run, right? Those are considerations that are being brought up at code development. And again, it can have an impact on how that building is sized, that system is sized, and how that building's going to operate. Beyond mechanical, like we said, there's going to be surface water heating systems, hot water boiler systems where we may be using both one tank to do both hydronic heating and surface water heating. How do we make sure we size it properly? These are all considerations that we'll talk about when we get into some of those surface water conversations. Now, lighting controls is pretty simple still for most of the energy code compliance side of it. It's all about lighting efficiency for the 18 and the 15 codes. When you get to 21, we start to get into what is expected when we talk about exterior lighting controls and more importantly, interior lighting controls. For the most part, what the code will begin to look at in the 21 version is the 21 says, well, let's back it up. The 15 version of the energy code for lighting says that you have 75% high efficacy light bulbs installed. Well, that kind of changed by the market, right? The market just made it, hey, why would you separate high efficacy from normal incandescence? Let's just go all in. And the market's changed that direction. At 18, it went to 90%. By 21, it's 100% of all lighting fixtures inside the residential unit have to be high efficacy lamps. More importantly, it starts to say in those certain habitable spaces inside the residence, you have to provide a dimmer or occupancy sensor, a control that allows people to dim the amount of light they're using. So it's not an all for nothing kind of environment. So that's a huge conversation. I literally just read before getting on class where a design company, some design firm, was actually sending out emails to jurisdictions, and this one was a state jurisdiction, state building officials saying, hey, we don't, our clients are saying that there's not enforcing this requirement. Can you tell us what you're doing to encourage? It was an ISO rating, right? Can you tell us what's going? And so, again, as you think about it, there may be requirements to have dimmers by the time it gets to the 21 version. 24 goes a little bit further than that. It gets into what size bulbs you can have, or what wattage lumens per foot can you have in a building. So again, things to think about when it comes to how we address those. What the code starts to do in the 21 version versus some of the earlier versions, it says, hey, if you're going to have exterior lighting that uses this many, I think it's 35 watts or more, we'll get more into that when we get to it. If you're going to use more than a certain amount of exterior lighting, give a control, turn it on, turn it off, right? Instead of like the farm version, which is, well, that light's not on my power switch, so it never turns off, right? So again, we're going to make sure that not only we have the right efficacy bulbs within the building, but then in the 21 version, you start looking to make sure, hey, do we have dimmers or some other control to allow people to dim their lighting systems? Sometimes you'll get that in different formats, whether it's going to be a more detailed lighting fixture schedule or electrical notes. Again, that's completely up to the jurisdiction and the designer as to what we're getting. This one here, like we said, it tells us some things are based on compliance path. This may be a requirement under their compliance path because they're calculating how much energy is spent lighting the building versus, again, you know, how many times have you left the house and left all the lights on, right? So again, when we start talking about those exterior lights, it could be something that we'll find in fixture schedules, like we said earlier. We may see that in multifamily housing, especially when we start talking about those lighting systems that kind of migrate across different units, right? So we're going to put in some astrometric switches that say, hey, when it's dark out, we turn the lights on. When it's light out, we turn the lights off, as well as maybe a time clock that says, hey, we'll leave the lights on till 10 o'clock, and then we turn them off, and they become photo cell or motion activated, right? There's going to be some potential things that we see come out of multi-family exterior lighting considerations that don't come from our traditional single-family, two-family dwellings. And again, I think that for the most part, most of us understand how that would be different. If we have, it's one thing to pull into your own driveway and have no lights. It's completely different when you're pulling into a multi-family facility or a multi-user facility and there's no exterior lights, right? Because there's, and we'll just leave it at that, right? There may be some different concerns that people have when you pull in the driveway, and I can probably tell if there's somebody at my house and what I'm doing versus I pull into a condo association or a assisted living facility and I don't know, is there someone around the corner? And is it going to cause me to, maybe not necessarily in a nefarious way, but again, if I turn the corner and there's Bill, my neighbor, I'm scared to death and I drop my eggs, then again, that's going to be, just one of those inconveniences that again, the code is saying, not only do you need to provide that light, but you also have a way to manage the energy associated with that lighting system. So, like I said, today's class is really more of that high level overview to kind of trigger or get in our minds some thoughts about what we want to talk about in the weeks to come. So if you have questions, comments, you always can put them in the chat, put them in the QA, reach out to me personally. Like I said, next week, we're going to start talking during our normal webinar about the documentation that should be submitted, you know, especially when we start thinking about some of those performance rating alternatives. I think the more and more that we're seeing, I at least see a lot more ERI capable companies or focused or the performance rating companies coming into markets. There was a huge push for several years, and it still is a push to get more trained staff on how to run those calculations. A lot of design firms are now hiring part-time people to do that work, because some of that, as you know, I sit on a couple different standards development committees for the ICC, and one of those specifically that was created in partnership with the energy rating industry was related to virtual inspections to perform energy rating inspections. So again, I think once that standard is actually is out for its final review, and I don't think there's anybody going to comment on it, so it should be published hopefully by the end of the year. And at that point, then again, those energy rating people might be able to do an energy rating in Amarillo by a cell phone, right? And they can do them. There's some things they can do at the office as far as the calculations, and then those verifications. There's a protocols will be in place to allow them to verify through a visual virtual inspection, right? Or maybe once in a while you come out, and again, there's a whole variety of different things going on in there. But again, what does that documentation look like? Then we'll get into the third week of each month. Third week of each month is going to be our inspection series. So this is plan review is first week, inspections is third week, and then we'll get back into some other our conversations. We'll be breaking down the res checks and at the end of the month to kind of, again, walk through what is res check, how does it work, how does it look, how do I compare, all that kind of stuff. And then we'll get into the mechanical. I'll probably miss a couple of those just because of some scheduling conflicts. So you'll see Hope and Andre and Jesse come in. A lot of that, I think this class here on the 24th is going to be one that Andre is going to teach as well. So we're trying to spread out the number of times you see everybody to make sure everybody's involved in part of the relationship building process. But again, getting into that mechanical, whole house mechanical design and ventilation is going to be kind of fun. Like I said, if you weren't on at the beginning, remember we do have Codes and Coffee or Building Community Coffee on Friday the 18th. Right now that's scheduled for the Habitat for Humanity on Paramount, but it may move to the Texas Panhandle Builders Association on Enterprise Circle. If you are thinking about coming, just send me an email. That way I make sure I get enough donuts and coffee. Or if you want a kolache, let me know. If there's some other breakfast item that you'd rather have for coffee, let me know. And it'll be 8 to 10. We'll have a time of conversation, free coffee conversation. And then we'll do a micro training. Like I said, it's really going to be focused more on doing that significant comparisons between the 18, the 15, the 21, and the 24. You know, where do we see differences, and what are some positives and negatives of that? Those differences. So again, I think it'll be a great conversation, and I really look forward to it. That is again, like we said, is something we reached out to the TPBA and to really get them to get more engaged in that. And so we're glad they're hosting it. I know there is a Panhandle Building Inspectors meeting or Panhandle Inspectors Association meeting, I think on that Wednesday. I was not able to get the TPBA to reschedule their entire event to make it work. So again, there's a lot of things going on the week of the 7th, the 16th through the 18th between Inspectors Association meeting. I don't know what the topic is. I know there's a happy hour with the builders on Thursday. There's a legislative affairs government affairs meeting on Thursday that I'll be there for, doing a presentation about code development and resources. There's a Texas Municipal League event Thursday at the convention center. And then again, like we said, we have coffee on Friday. So if you do have questions, feel free to reach out to me. Use the helpline. You can always use our survey to give in different topics of conversations or maybe questions. If there is, again, we're here to provide any resources we can. And if that means, scheduling some in-person trainings for your team, please let us know. We try really hard to be as flexible as possible and get in and share different information for different jurisdictions. I know we've done trainings both in Dumas and obviously Amarillo. We are looking into some other, specifically partnering with the Inspectors Association to do some that are maybe a little bit further north, and maybe Borger or something like that, or maybe even going all the way up to Perryton. But again, if you have opportunities that you want us to kind of take a look at, please make sure you let us know. We'd love to participate and share that information. You can always throw our number and our information out, our email address to the Texas Panhandle, or the TX helpline at shumpscoda.com. And we can, if there's any way we can provide some resources, education, questions, answers related to the energy codes, any of the energy codes. I know I just got the 21 on the picture, but any of those resources we can help, we're there to help with. Throw away. The website is still working, but it's under development. We're hoping to get some transition. I think Hope had a meeting with them about a half hour ago to see where we're at on that. But if there's any specific technical resources that you think we can best create to facilitate and help you along the way, let us know. Like I said, haven't got any feedback on our inspection handout yet. So let us know what you think about that. And then hopefully, like I said, by the time I get there for the coffee, we'll have one for plan review. But I appreciate everybody joining on today, and I hope that you have a great and fun long weekend celebrating Independence Day. Take an opportunity to thank a veteran, and for those families of veterans who have served alongside them as they protect our country. I appreciate each one of you. Have a great week, and I will see you in a couple weeks, if not next week, online.